Hello friends, I am Siva Krishna. I am part of Oracle. Today I am going to talk about DevOps Lifecycle, a little bit of tools that typically we are using it, and the need for unified platform, etc. Here are my coordinates in case you wanted to reach out post the session. So I was reading an article other day. The foundation for DevOps started with Agile 2008 summit. So wherein Patrick Du Bois and somebody else had an argument in taking Agile infrastructure with the kind of steroids, how to take it forward for complex applications. And later in 2009, there was a Velocity conference that happened. In that, couple of Flickr employees had shown how to deploy 10 plus builds in a day. So typically that was the foundation where Patrick Du Bois attended this seminar over a video streaming, and later the concepts of Agile was taken forward and applied in Flickr, and thus the word DevOps arose. So the foundation for DevOps actually started exactly 10 years ago. So we embarked in this journey almost a decade back. But fundamentally, when we approach the developer segment, they ask what is DevOps, a simple definition of it. So when we look at the Gartner or Forrester kind of analysis, or every alternate blog, we get into different definitions. Gartner says is a tool-centric philosophy around continuous delivery value chain. And Forrester comes up with a COMS approach: culture, automation, lean, measurement and sharing, etc. This is all complex. At the end of the day, it is nothing but simple modeling the tasks that are being performed by application development and systems operations put together under one bracket. So what we are going to achieve is to reduce the wall of confusion between both the teams and try to strive for a single delivery model. So what I am going to talk about is the life cycle and the typical tool chain that has been used in the industry and that is required for any typical project, and couple of use cases, and then the need of a unified platform, etc. So the life cycle. Just get into Wikipedia site or any other sites you see, these are all the patterns or the stages in the life cycle, starting from the planning to code, build, test, package, release, deploy and monitor. These are all the typical patterns that are constituting the complete life cycle of the DevOps. In this, at each and every stage, there are categories. Probably from a tool-centric perspective or from an operations perspective, there are categories. If you look at the Gartner DevOps maturity model diagram, they categorize these segments into the four. One is technology, people, processes, and the cultural aspect. So if we deep dive, probably the given time slot of 30 minutes is not sufficient. But what I mean to say is, there are a certain business process that need to be done at each and every phase, and there is certain tool set that is required to cater the requirement of it. And the green and blue and red, three different legends are there, you can see it. This red pattern, all these patterns are required a unified development and team infrastructure. And the blue dot, that indicates that the runtime that is required, whether you are deploying to a simple compute VMs or a Docker or a Kubernetes architecture or anything. And finally, the observability space is the monitoring thing. And because it is a spiral approach, right, there is no starting and there is no ending that is being shown. So where to start this? So in the Gartner model, they say you can kickstart the DevOps from people's perspective, a technology perspective, process perspective, or a cultural aspect. So I found a simple way that people are practicing it, and it's been shown at multiple sites. Kickstart the Agile, then get into the continuous integration, then mature it, harness it further with the continuous delivery, and over a period of time you get that maturity. So Agile is the foundation, then continuous integration, then getting into the continuous delivery. Okay, the tool chain that is required to cater all three has to be discussed here. As I told you, we need two set of software to achieve this agile and further to continuous integration and delivery. So if you categorize them, development infrastructure is one thing and team infrastructure is one thing, and just look at from toolchain perspective at each and every place. Team and sprint management. So here we need a software or the tools that caters the requirement of project management, adding the users or the creating a group of people, attaching it to a particular project, and understanding the activity stream that is being done by that particular team against a project, and if that project has multiple repositories, against the repositories we need to understand it. Then agile process management, having a Kanban kind of dashboard or any other dashboard that you wanted, and managing the sprints and adding these your backlogs to the sprints and understanding the progress of it. We need a agile process management. And then finally, for issues tracking, we need tools something like a Bugzilla to note all the issues, bugs, defects, etc., and tracking it up. Then it gets into the peer code reviews. Source code repository, per component probably I need to have one repository, and per module I might be having a repository. Thus I need more and more repositories against one project implementation. Then the code reviews are required. There is a separate software or a tool chain that is required to cater the requirement of tool chains. Then finally different markup types that I may get into, Confluence or Textile or Markdown, any kind of markup framework that I need for documentations. And finally activity stream, where the lead of the project etc. can see the complete holistic picture of what is happening in that project, either the builds or the peer reviews or the documentation, everything scrolled at a single place to see that. When it comes to development infrastructure, source code obviously, which supports all sort of features of the source code management system, and then automated build and test environment, where a lot of frameworks that we anticipate to be made available. If it is a simple Java project, I need Ant and Maven. If it is a JavaScript, probably Gradle Grunt kind of thing, or if I am creating an image for Docker, I need that kind of tooling made available. When it comes to the testing framework, again depends on the language, I get into the testing frameworks. Then from continuous integration piece, where I need to create multiple builds and plumb them with pipelines and see how to make it reusable jobs across multiple pipelines and navigate through that. And continuous delivery, wherein the deployable artifacts I capture it and push it to the artifact repository and creating and managing it and pushing it to the release management cycles. And continuous provisioning is one of the aspects where to make it the elastic infrastructure made available in terms of a typical compute VMs or a Docker kind of environment, etc. Now, couple of use cases where typically I have seen pretty simple use cases, you can see, wherein JavaScript application is being considered. Now the JavaScript application is being pushed to the code repository, and when the build jobs triggers, the typical unit test I might be using a Mocha JS framework, and for the load test I might use Artillery. Then I get into the build stage, wherein I just capture create a Docker image for this and package it, and finally I wanted to deploy to the Kubernetes architecture. So this entire cycle has to be evaluated in terms of the tool set and the libraries made available at my continuous integration server. What if I wanted to leverage a post deployment, I want to leverage integration testings. So this particular step will be extended with your own frameworks, probably for example web markup API. I want to deploy the API first with the test code, sample code, etc., then deploy my application and test against the mock API. So there are use cases like this, and from an infrastructure provisioning perspective, probably now over a period of time again we matured into various configuration tools, various replatforming tools, etc. Use a vendor API to download the base image and then create a configuration management tool, and make use of a packer to create your custom image, etc. Then finally write a Terraform script to provision that infrastructure onto typical IaaS. So there are a couple of use cases from a tool-centric perspective. When it comes to the agile practice perspective, I wanted to show you one of the internal use case that we use for one of the projects internally. So for this particular project has 40 different Git repositories internally, and for every component we have a separate Git repository. Now across all the developers per week, almost 200 commits happens. Every commit triggers to a build process. You can see the multiple iterations happens over the code reviews, etc. And finally, end of the day, it is going to commit these changes to the master branch of the component repository. And whenever we are preparing for a particular release, quarterly release of this, we will carve out a release branch from the master branch and attach all the source code that is being committed to that particular bug fix, etc. And then create the automate build and carve out the release and commit to the main master branch. And apart from this routine the commits or the builds, we do almost 2 times a day integration builds. These integration builds help us to identify any early bugs, etc. And this is one thing from a dev standpoint. And from production point, we do this almost every 2 weeks. We master is being branched out for every 2 weeks and do all sort of tests, including the manual QA, and push it to that. Now you see why the unified platform is pretty much required. It has been addressed by previous speakers as well. Probably, if I need to have such tool set for team infrastructure and application infrastructure, various plumbing has to be done across these frameworks. The moment I kickstart a new project, I need to provision this entire infrastructure for that project made available. Probably provisioning of all such things might take a couple of weeks. So what if for every given project, if I can provision this entire environment in a matter of 1 or 2 minutes time? That is where we have a product called Developer Cloud Service. The moment you kickstart a project, just mention whatever the markup style you needed, what is the base template that you wanted to start with, and all these tools, the best of breed tools, are being baked up into this, and you don't see any interface of the tool centric ones. You see a unified interface of it. So this is the only product slide I kept it intentionally just to show you the demonstration of it. Starting from Git support or GitHub, probably you can take it up, and from then use the framework of Ant or Maven or Gradle and compile the code base and keep it. And we have a Hudson continuous integration server baked behind the scenes, and a deployer component that can deploy to any target or platform. So from a testing perspective, we support multiple testing frameworks, JUnit or Selenium, find bugs, etc. Okay, we can integrate with any kind of third party, and it has integration tightly integrated with all sort of IDEs, including Eclipse. Okay, now I'll just run through the demo. So this is the front screen where you can just kickstart your new project over here. Click on the button New Project. Then
the Oracle Developer Cloud Service. From here we can see all our project and select a specific project on which we want to work. Once we're in the project, the environments gives us the status of our cloud services, and the activity stream shows us the history of our activity in the project. On the right side we can see our repositories such as Git, Maven and Docker repositories, our statistics and our team member information. In this scenario we have a deployed application in which a bug was found. The first thing we are going to do is go to the issue tracking system that is built into Developer Cloud Service and add a new issue to our issue tracking system. We can fill out information about our issue in multiple fields. We can reference, for example, information in a
just
wiki
forwarding this creation
feature. Here we can indicate a target date for completion of the. Once an item has been inserted into our issue tracking system, it's available through our reporting system. Next, we're going to look at some of the agile capabilities of Developer Cloud Service. Here we see our backlogs of issues. We're going to create a new development sprint, associate a complexity level to that sprint, and then we are simply adding items that we want to handle in the next development sprint by dragging and dropping them into the sprint. Developer Cloud Service keeps tab on the amount of complexity we are targeting, and if we are breaching this amount of complexity by adding too many issues, we'll get a notification up here. Once we're ready to start our development sprint, we simply click the button, and we can indicate the length of the sprint, and once the sprint is running, we can go and see our dashboard. Developer Cloud Service supports both Kanban and Scrum dashboards, and over here you can see the various tasks and the owners of each task and the status of each task. In addition, a collection of charts and graphs help you track your progress as you walk through your development sprint, as well as look at the history of your performance in previous development sprints. This helps you manage your team effectively. Next, we're going to switch over to the point of view of a developer. The developer can access Developer Cloud Service in the same way from the browser and look at the same project and notice there's a new issue that has been assigned to him. He can then go click on the issue to get more information. To fix this issue, he needs access to his code. The code is available inside our code repository. Developer Cloud Service provides you with private Git repositories that you can manage. Here we can see our Git repository and we can navigate through it. In addition, we can create a new branch for our code. This will allow us to make changes to the code without influencing the master branch. The Git repository also supports smart code-aware searches. So based on the context, we can search for a word and Developer Cloud Service would show us where it appears in our code. Once we found the file that we need to modify, we can go over and look at the file. We can then directly edit the file from inside the web interface, or of course extract the file into an on-premise IDE or a cloud-based IDE using regular Git commands. Here we made some changes and we're going to commit the changes back into our branch, indicating what changes we did and which issue they relate to. Once our code is complete in our branch, we might want to merge it into our master branch. We're now going to start a new merge request, which involves a code review before we actually merge the code. So we indicate from which branch we're going and into what branch we're targeting. We automatically recognize the commits that have been done. We can indicate which issues this commit is related to. And we can have a reviewer from our team review our code. We can give them some information about the changes we made. In addition, we can have build results be part of the code review. For example, build tests automation that might indicate if the code is of good quality. Now let's switch back to the other developer and look at it from his view, where he can see that a new merge request has been put in his queue. He goes in, he can see the remarks that we provided for him. He can even see the exact changes in code that we did. He can then go ahead and give us comment on specific lines of code. This can lead to a discussion about the code. Once we're happy with the results of the code, we can approve it for a merge, and we can also execute the code merge directly from our web browser. In this case, we're going to merge the code and delete the branch and close the issue that this relates to. Once the code has been merged, we're going to show you the next step in our process, which is build automation. You can see that the build has been queued for us automatically the minute that we made the change to the code. This build is part of this pipeline over here that has multiple steps. Let's look at the configuration of the build. This build is connected to our Git repository and is automatically executed every time that someone commits code into our master branch. The build itself executes a Maven command, but as you can see here, there are other types of commands that you can do in the build, including Docker, Ent, Gradle, npm, and many others. In the post build, we are archiving the artifacts, and again we can do other steps here, such as publish test results. Here we can see the history of our build, as well as a live view of what is being executed, and we can even go and look at the log file for each one of the builds. Now that the first step in our pipeline is finished, the next step is queued automatically for us. This is the pipeline which you can edit visually in a visual editor. After a build is complete, we can automate also a deployment. This is what we're seeing here. We can go and see this configuration of this deployment, which is automatically fired every time that this build finishes and produces a WAR file. We're going to take the artifact and automatically deploy it, in this case to a Java Cloud service in the Oracle Cloud. You can now see that the builds have finished and our queue is empty. We can see the results of the build. This test actually failed, and we can go in and see some of the test results directly in here. In parallel, we did a deployment, and we can see the deployment over here as the last step in our process. We can then go directly and open the deployed application. And we'll be able to see our changes for the title implemented in the deployed application. You've just seen a complete DevOps cycle done in about 10.
Okay. So here you can see the complete Agile practice, and from there it has gone to the team infrastructure for reviewing the code base or modifying the code base online. Typically we do in our own IDEs and commit it over there, and automated build process has picked up for every commit, and build has happened and tests have happened, and finally a deploy component is kicked up to deploy to any of the cloud services, or even in your on-prem we can deploy to that. So and couple of queries that came from customers wherein they can't come out of the existing investment in terms of issue tracking systems or a continuous integration servers, wherein how to make use of that or tightly integrate with this. So we came up with a open webhooks interface to plumb any of your existing investments, and so that you can't you don't need to really make use of that particular feature in the developer cloud service. So webhooks is the way how you can integrate with the Slack channel and publish your automated build results, etc., into the Slack channel, etc. Or even Jenkins, if you are already set up the Jenkins infrastructure and making use of it and wanted to take a transition time for some time, you can make use of that. And the other part of it is this product comes at complementary with any of the cloud services that you take from Oracle. So there is no charge for this. You can just go ahead and make use of it for any number of projects, right? So I can take up a couple of questions, otherwise I'm around at Oracle booth over there, where you can take the cloud credits and practice this particular product along with other cloud services, etc.
What kind of automated test frameworks are we talking? Like GitHub or like JUnit kind of?
Yes, we have inbuilt support for JUnit, Findbugs, Selenium, etc. And if you have your own framework or library, we can download that library into the continuous integration server at runtime, and you can perform your tests over there. So there is no bar, but out of the box in CI server we are providing these libraries, and in case you need, if you have a repository set up like a Maven repository wherein I can directly download on the fly and make use of those libraries referencing, and you can perform tests and conclude the reports.
The agile method that you said about the tool and all, if you want to use that functionality, we'll have to buy the whole tool, or we can take only that functionality and use it.
Okay, this entire tool is baked up with the complete integration of all the framework. This tool as such comes free with any of the cloud services you take a simple compute cloud service or any other PaaS services from Oracle, we give this tool as a complementary to kickstart your project. So you can make use of only Agile framework and discard the rest of the continuous integration and testing and further deployment. That is up to you.